Then the last sort of descriptive method would be a correlational study. And this is just taking two variables and trying to see if they're related or not. We plot them on a graph and then look at how the data is spread out. And so on the top there, we have like a positive correlation, which is where we can kind of see the line going upward and to the right. In the middle, we have a negative correlation because it's going down. And then if the dots are all just spread out on the graph, there's really no correlation there. And so an example of something that we could plot to see if it has a positive correlation would be height and shoe size. And we typically could infer that the taller you are, the bigger shoes that you wear. And so that would look like something towards that positive correlation graph there on the left. As one goes up, the other goes up. And we would see that plotted together. While I'm talking, can anyone think of something that would have a negative correlation? What that means is one of our data points increases, the other data point would decrease. So think about that for a second while I'm talking and see if you can come up with something that would have that sort of a relationship. And so how we measure in a correlational study is we use something called a correlational coefficient. And that's a number that you have to understand and know where it comes from. And so there's a couple parts to a correlational coefficient. The first is the plus or the minus sign. And so that indicates the direction of the relationship. If it's got a plus sign, it's a positive relationship. As one number goes up, the other number goes up. If it's got a negative sign in front of it, that means it has a negative or an inverse correlation. So as one number goes up, the other number goes down. And so my example for a negative correlation would be as the temperature increases, hot chocolate sales would decrease most likely. So as one number goes up, the other one is decreasing. That's a negative correlation or an inverse relationship. And then the actual number in the correlation coefficient tells us how strong that relationship is. And a correlation coefficient can only go from -1 to 1. So if you're getting a number like 7, that's not a correlation coefficient because that just doesn't exist. The number has to be from -1 to 1. If we had a plus 1.00, that would look exactly like that blue line in that first image. It would just be an exact perfect straight line. That means that, you know, they go up together at the same time. Yes, it is necessary to know about correlations for the AP exam. Someone asked a question there in the chat. Typically, sometimes they'll actually show you a graph like what I have here and ask you which number best represents it. Sometimes they'll show you a number and ask you to describe like the relationship that exists based on the number, but it is something that definitely comes up probably almost every year on the AP test, either in multiple choice format or in the actual written part. So I would definitely make sure you don't need to know specifically how to calculate the number. You just need to know what it represents. So -1 then would be the same as +1, except it's the downward slope line. And so as we get closer to 0, the more scattered out our data gets. So if we look at the one that says no correlation there in the upper right, that one's going to be like a 0 because there's no line forming there at all. The data points are all spread out. And so if we had, I actually just kind of wrote out here what it might look like. R is the variable that represents correlational coefficient. So if you ever see like R equals, you should know that that's a correlational study that they're referencing. R equals plus 0.98. That would probably be that first graph there for positive correlation. It doesn't form an exact perfect straight line. There's a little spread in the data points, but it's pretty close. And then the middle one where it says negative correlation would probably be like an R equals -0.96. Again, not a straight line, but the data points are pretty close to a straight line. And then the last one, R equals 0.12. There's just a lot of spread. We really can't make a representation by looking at the graphs. So that's correlations. I would really say the big thing is practice looking at a graph and understanding like the data points and what that tells us, and then making sure you know that the R equals and what that number means. And there's a lot of practice questions out there where you can just look at a graph or a chart and then answer that question based on the chart. And so you can get a better feel for it. The reason why in a correlational study we have to be careful, because we still can't determine cause and effect, is because it can predict the relationship, right? I'm looking at how many hours of video games you play a day versus your grades, and I can predict what that relationship is going to be. But again, I can't necessarily predict why. And so a good example of that is here, why we can't use a correlational study to necessarily predict cause and effect. Because if someone has low self-esteem and depression, it could be that your low self-esteem, the way you kind of think about yourself and the way you interpret yourself, causes you to feel depressed and have depression. Or the fact that you already have depression could impact your self-esteem, and it might make you feel bad about yourself and have lower self-esteem in general. A correlational study doesn't tell me which causes which. It just tells me that there's a relationship there that exists. Or there could even be a third factor here. There could be a distressing life event or a biological circumstance that causes both low self-esteem and depression. And so without actually doing an experiment and further studying that, I can't make a conclusion about that with my correlation. I can just say, yep, I know a relationship appears to exist there, but I don't necessarily know why and in what direction that relationship goes. So please be careful, because I think with correlation, sometimes it seems like we're making a conclusion that this causes that. But in reality, we're just saying there's a relationship here and we need to investigate more about that relationship. And just for a little fun, I like to always look at this website. There's more of these, but they're called Spurious correlations. And basically, this is just a warning to always kind of be wary about the data that you're looking at. The red line on the first one here is total revenue generated by arcades in the United States. And then the black line is computer science doctorates awarded. And it appears that those two numbers are correlated. They move pretty strongly together. And if you actually can see the number there, they're a pretty high correlation. It's 0.98. However, you actually have to think about that data. What would those two things have in common? And if the answer is nothing, then you kind of have to question the source of your data. And I think that's especially true if we look at the second graph there. It's per capita consumption of mozzarella cheese versus civil engineering doctorates awarded. Those two things have nothing in common, but for some reason their data points actually kind of coincide and they have a strong correlation relationship. But again, being a good scientist is also thinking critically. And so in psychology, we kind of have to question the information and always be a little critical about that and make sure we're not being tricked into believing something. And so the guy that made these, if you Google spurious correlations, he's got a ton of other ones that are kind of funny. There's like something about Nicolas Cage movies and like the murder rate in the United States. Those are correlated. So that's kind of funny.